Hi, I'm Ryan Lembitz, and this is my senior project on iPhone LCD remanufacturing. Our story starts with a more than common occurrence in the 21st century. You're walking along when suddenly you just lose grip of your phone. You go to pick it up, and unfortunately, the screen is totally destroyed. You have about two options. You can buy a new phone from Apple, which the cheapest new one is about $700, or you can get your screen replaced locally for a much more affordable price. The typical repair process looks something like this. The damaged glass with working LCD and digitizer are removed from the iPhone. Then, all small parts are removed from the damaged glass with working LCD and digitizer. A new panel is tested, and then all small parts are reinstalled back onto the working LCD digitizer with uncracked glass. Then this assembly is reinstalled back onto the unibody of the iPhone. The repair results in a great-looking iPhone screen, free of any defects or cracks. However, as a byproduct of the repair process, we're still left with a good LCD and digitizer with cracked glass. The problem in this repair process arises from the byproduct. Repairing iPhone screens on a mass scale, we are left with hundreds of working LCDs and digitizers, yet they are rendered useless because of their cracked glass. We saved our stock of broken iPhone screens for 1 month, and this is what we got. Although remanufacturing processes are available, they are expensive and do not meet OEM specifications for durability and therefore cannot be used for subsequent repairs. In order to successfully solve this problem and reduce the waste and environmental impact caused by the screen replacement process, it is essential to remanufacture the iPhone screen by first reclaiming the working LCD and digitizer and then installing the working LCD and digitizer onto new glass. This will reduce overall cost so long as OEM durability specifications are met by the remanufactured screen. In the far left of this picture, we can see the byproduct of the screen replacement process. On the right, we can see the working LCD and digitizer with its OCA glue and polarizing film still intact. The polarizing film and OCA glue will have to be removed in order to successfully reclaim the LCD and digitizer into a state in which it can be remanufactured. On the left, we see the working LCD and digitizer with the old polarizer and OCA film removed. A new polarizer and OCA film will have to be relaminated by vacuum suction machine in order to allow its relamination onto a new piece of glass in the center. On the right, we see the final product of the remanufacturing process, a complete screen assembly which can now be used to replace another broken phone screen for another customer. Once remanufactured, the only main consumable used will be the new glass, OCA, and polarizing filter, which are estimated to cost around $7 per phone. This is a considerable economic benefit as compared to the $60 a screen that is normally paid for an assembled LCD digitizer and glass combo. However, for this benefit to be fully exploited, it is essential that the remanufactured product meets all of the same specifications as the OEM product on the original Apple iPhone. After understanding the basic approach to the solution of the problem, more research had to be done to successfully finalize the remanufacturing process. A large amount of research time was devoted to specifically OEM durability standards and the required manufacturing design requirements which must be met to achieve these standards. These standards included a screen and frame assembly which are stable at high and low temperatures, a required adhesion strength for laminating the LCD and digitizer to the new glass, as well as the constraints for optical clarity of consumables used. It was then found that the current state of remanufacturing did not achieve OEM standards, and alternative solutions must be generated in order to achieve OEM durability quality from a remanufacturing process. These alternative solutions included the use of cold, chemically bonded frames to achieve stability in the product at variable temperatures, as well as the use of OCA film versus LOCA glue in order to achieve the OEM required adhesion strength. Many types of machines were also researched in order to carry out the various tasks required, with emphasis on ease of modification to accommodate cold, chemically bonded frames. Upon initial literature review, it was found that there was one main deviation from the current state of the remanufacturing process, and that of the OEM process. On the left, we see the results of a standard remanufacturing process, where the plastic bezel frame is laminated onto the glass instead of cold chemical adhesion processes which are used in the OEM manufacturing environment. This results in a frame which is poorly adhered to the glass, and ultimately a screen which has very low durability and has a life cycle which can be assumed to be under 1 year. As a 1-year life cycle for a part like this is absolutely unacceptable, the current standard of remanufacturing will have to be modified from using hot melt glue to using cold chemically bonded glue to adhere the frame to the glass bezel. This will require significant modification of all existing remanufacturing processes for iPhone LCD screens. With the completion of the literature review, the objective becomes increasingly clear. In order to decrease cost and inherent waste associated with this screen replacement process, an in-house remanufacturing line capable of processing cold, chemically bonded screens with OCA film adhesive is necessary in order to achieve OEM standards of durability from a LCD remanufacturing process. Additionally, a DFM will be created in order for this process to be easily replicated and scaled if or when demand for OEM quality remanufactured LCD screen spikes. Currently, machines have been selected and purchased and await modification for cold, chemically bonded screen processes. In order to properly validate the process, LCD and digitizers will be tested after each process step, and defects classified in an attempt to find the largest impacts on yield loss. Methods will then be taken to combat these yield losses in an attempt to design the most successful process with lowest loss of yield. Additionally, as the standard remanufacturing process follows the process flow of LCD to glass lamination, then screen assembly lamination to frame bezel, new jigs and fixtures will have to be developed to accommodate the new process flow. This new process flow will follow glass to frame bezel cold chemical bond, then OCA film lamination of LCD to pre-assembled glass and frame. This will require extensive modification to the process seen here, as the product being input into this machine will be a complex three-dimensional shape with frame attached, as opposed to the simple flat panel in which the machine was designed to accommodate. Thank you for your time, and I look forward to sharing my progress and optimization of this process more with you next quarter.